Okay, let's go ahead and get started and people can join us as they come in. So it is my pleasure to announce our next webinar speaker, İlkay Altıntaş, who is the Chief Data Science Officer at the San Diego Supercomputing Center at UCSD. And she will be speaking to us today about the National Data Platform. So without further ado, please go ahead and take it away. Okay.
Thank you, Nicole. Good morning and happy New Week, everyone. I'm going to talk about, as Nicole said, the National Data Platform. This is a joint effort with UC San Diego and University of Utah and University of Colorado Boulder. So the things that I'm going to talk about is the work of many colleagues in these different institutions and other partners and collaborators. So why do we have the National Data Platform? Didn't we have enough data platforms, right? Turns out we didn't. There were some gaps, and those gaps are informed by or influenced by the changing science and application continuum. Typically, bringing AI into science requires bringing big data from different sources in ways that we didn't before, like edge computing and sensors and this autonomy through robots and other things become a part of science. And these all are sort of coordinated with AI or made easier to integrate into the modeling and simulation and other scientific activity with AI. But then we need to be ready for this, for AI in science. And it's not just science and AI methods. Right? We need to be able to federate data from many sources. We need to trust the quality and volume that we can actually integrate into our science. We need to manage knowledge as insights, scientific insights, and the rest of the things like benchmarks, scalability up and down, things that we did in computing, workflow management, software integration and engineering, DevOps, now sometimes they're called AI ops or data ops. These also become a huge part of challenge actually here because we are actually changing all of that also to bring them to the AI world, so to say. And then more use of AI requires more trust through interpretability and explainability of that science. So using actually AI in science is different than using AI in, let's say, marketing applications, right? There's a lot more need for interpretability and explainability there because a lot more expertise is needed to understand those products. And then to bring our workforce, both upskilling our science workforce, but also creating a culture and incentive environment to do more of this together. So there's a lot going on here that we are trying to make sense of all together as a community. And it requires more and more full team integration. Right? There are many people contributing to our science activities from different backgrounds, different expertise. And also there's a need for enabling data platforms, so to say, to do that kind of work. So how do we sort of bring our own ropes into the thing and create a nice science that we weave these together almost? Right? How do we seamlessly integrate AI together? If we are going to call something AI integrated into our application workflows, and how do we collaborate to do that? These are the things I was having and many of my colleagues were having also in educational settings as well. So it's a workflow issue actually, but this is a neat type of workflow issue because it requires a digital environment that's built for composition. Dynamic composition matters in this context when we are going to be data responsive or insight responsive or intelligent, so to say. Why is something smart or intelligent? Because there's some sensing in it, there's some reactive behavior in it. So this is a different beast to integrate and dynamically act on. So computing requires some urgency and composition to it as well. It requires, in that sense, system federation. I'll talk a little bit about that. And then reusable services that bring capabilities that we can integrate into applications. And then we need to have environments that integrate services into solutions, those workflow-driven solutions that bring AI and other forms of problems together. Also, as we know, AI needs data. It requires data. Without data, we don't have AI. We need to be able to think through how do we invest in data federation, data from many environments. For instance, for facilities, how do we make sure facility data can interoperate with other data sets and be a part of scientific knowledge through maybe readily available standard data services, but also broad access to it so others can build services on top of them. So that's another challenge sort of we are all experiencing and facing. And data, of course, even in small forms, data can be pretty frustrating. Data sometimes is in repositories and we have bookmarks and notes to it. It can, as you very well know, in this community, can come from facilities, links to limited data at times in AI context happens, or services that we might want to use it a little differently, but we need access to the full source and the facility isn't built to provide that as a service, but can I build mine and integrate into an application? It can be something that's challenging. Personal files like zip files, many drives and emails. I've worked with LiDAR data even at times, and I see a lot of things in Google Drives being mailed to me over the years. Data in repositories that we can extract, transform, load sometimes has unresolved dependencies, or the environment the data is in to do that ETL isn't built for scale, and many other things. I can count many more along with this. And then when we self-manage this, which is most scientists' work mode, we have our data exports, we prepare things, and we still do. We sometimes have Git repositories that comes with scripts and extraction possibilities from the data, and how do we extract and integrate that into our own workflows. The idea is then we'll have the data ready, we'll have the scripts and other application tools and services ready, and we'll integrate that into a scientific workflow that we can use to compute and bring that scale into. It doesn't end there, right? Then we understand that the collaborators or collaborate. There's no one environment that built to collaborate on top of existing cyber infrastructure and data resources. So it becomes really hard to replicate our work in terms of reproducibility and also working together simply to bring our expertise together. And when it's all said and done, how do we manage and share data? And do we have a standardized approach with our collaborators at least, or an enabling environment that helps us to do this? Why are these challenges happening? Why is it so challenging? Because typically we have fragmented access to data model services. They're all over the place and they're not built for composition. What I mean by that is they're not built as a capability that scales as a service that we can bring into our workflows for the most part. They come with different formats. They are not interoperable or complex to interoperate across those. And they also don't bring an explanation on this data should be used for this context, or when it's used, this is the metrics it should collect with it. And this happens a lot because where we are producing data, typically, is different than when we are sharing data or where we are even using data, right? So that disconnect actually is hard to manage. And it's hard to sort of turn into a customizable service deployment practice on top of, because there are many different environments that data lives in and gets used through. And for each of these different needs, most of the time, again, with, of course, there are exceptions to all of these, need for scalable or specialized compute is actually relatively large. When we talk about big data, we talk about variety, complexity, and different needs, even storage needs for data. And how do we actually create a scalable environments to make them analysis or compute ready. And how do we use existing infrastructure for it, right? So if I'm doing research, can I use research infrastructure or commercial infrastructure provided to me through research credits? But when I'm teaching, can I also use that research infrastructure? Actually, I can teach with research data or research models, research services. So students can actually be brought onto this new world of AI a lot more seamlessly, so they can be the scientists armed with these things through their education. And a big part of it is in data, it took us a long time to think user experience. So, and that I think going on, that's changing in some efforts, but enabling collaboration through data and the user experience for that is still something we are learning to do. So when we put our heads together for, what does this mean? The National Data Platform sort of came through these gaps. These are the things that we knew maybe, but there are many more that is unknown. So the pilot for the National Data Platform was inspired by this to tackle these challenges around using and sharing data. So anything that involves using data through a broad, federated, extensible environment that's built for composition, so to say, as an ecosystem. So the idea here is then how do we promote collaboration of teams to do AI integrated things, science, education, societal scale applications? How do they innovate together, these teams and students that include students in data challenges? And how do we bring customizable use of data? So customizable being the reason we call it a platform, not a hub or portal or things like that. So National Data Platform in that sense is not a repository. It's a platform that enables use of existing repositories and cyber infrastructure so that we can actually extend these things to broader use and reach through usability and composability and interoperability as the principles. Again, usability, interoperability, and composability. How do we do this? NDP Hub is built for that usability context. We are trying to learn about what would be a generalizable way to make existing things useful in well-defined user experiences and workflows. And how do we enable collaboration with colleagues or learners, if you're an educator, through those usability interfaces? And how do we link existing cyber infrastructure to it in a federated, capable fashion? And then usability also includes interoperability, right? What are the standardizations that we can bring here? So we can bring data and models and services or tools and infrastructure in general from many different sources so that we become the usability layer through this centralized portal or hub, the way it depends on how we kind of look at it in a way. How can we discover, access, use within workspaces, different resources? Right? And how do we do it? Both for research and education. When we do it right, in essence, there's not much of a difference. Our ability to compute on large things becomes also a need for education in our new AI world. And then how do we bring in more composable things? How do we federate things into it? What would be a scalable platform for using, developing, and deploying composable services in a very distributed way? So can we, in that sense, go to where the data is, for instance, and build our own near data services and bring those into the standardized application in a deployable way? Or can we just take it private and do it there? So these are the things that we are doing and learning, and we'd like to see more of that if that's a possibility. So what are the flow of capabilities when we talk about usability or capable services and using them? They're really thinking of this, what's the flow? Again, this was the flow that we were trying to at least help with. Okay? and bring more collaboration on top of that. So when a user comes to NDP, they can find data, services, models in a catalog. If they don't find what they need, or they bring their own data, services, models, there are ways to ingest those or federate those into the catalog as additional workflow inputs or catalog discoverable items. And if, let's say, there is a composable service they're trying to build, there's a way to use the standardized NDP stack and deploy it as a development environment that one can build services near the data or near specialized computing resources so that they can be used as services within a workflow. Then one can create a workspace to add these things that they discovered and start collecting things, so to say, in a workspace for analysis. If it's individual work, you can then launch that workspace on a compute platform and use the tools. It could be simply a Jupyter notebook and hub that's workspace compatible, or within that workspace, we can think of using existing workflow tools or existing AI stacks wherever the service is capable of launching. And then once the results are achieved through that analysis or workflows, one can then store and export those final products into the data storage repositories of their choice, with maybe also a standardized way of, if they want to share, bringing these data sets as catalog items wherever they are stored with their DOIs and other access mechanisms. So this would be the individual work. And how does collaborative work fit in? Then we sort of built so far the ability to collaborate these using these workspaces. So one can then go to the Collab Studio and share these workspaces with collaborators. That gives them shared compute and storage capabilities on the National Research Platform or other Amazon and other on-prem sources, so that they can build research collaborations, they can build classroom assignments with large amounts of data and compute using research computing, or they can build data challenges. So there's a way to collaborate with students, or students to collaborate with each other to take a data challenge, or there's a way to create research collaborations in ways that involve the workspaces that different collaborators build and bring into the environment. So that's the main flow. Within that flow, then what does NDP help with? First of all, sharing things in the catalog to make them fair and used at scale. We had to we are still working with the community, of course, to ensure we can crosswalk from many types of metadata into a federated catalog in ways that bring entries that can be then useful through endpoints that they are served through. And sometimes that means registering data with a service. So what we access and use isn't the data itself, but a service that's data capable near the data, so they can be a particular step in a workflow in ways that maybe do like feature analysis or constrain the data to make it more useful. And then we are still working on, there's some capabilities on integration of vocabularies using different ontologies or knowledge graphs. But we are working on expanding these to ensure there is a conversational assistance and work with the data. We'll come to those in just a second. And then we also have, of course, collaborative workspaces, as I mentioned, and in ways they connect these workspaces into cyber infrastructure. So you can bring your own data and create your own services, but you can also bring your resources that you'd like to compute on to launch these workspaces on. And currently, some of the examples I'll give is then using these different types of capabilities and services within AI integrated workflows or classroom data challenge environments. And we know this doesn't capture it all. It's a pilot effort. NDP just completed its second year. And a big part of our approach here was to understand how we can use open data, existing data services and systems for integration for use. And a big part of that was also to try and understand what we don't know about these challenges. So there's a big needs assessment built into the approach here, an application co-design with collaborators like yourselves. Hopefully we get to work together more. And then using those application co-design and needs assessment learnings to create features and educational resources so we can also do capacity building. So the more we learn, the more we build, and the composition principle really helps us to distribute things. But when we look at the current user personas, researchers can find data, run compute and compatible data analysis, and collaborate across institutions and publish reproducible findings in NDP-compatible platforms. And researcher educators can then integrate their research-grade data sets and tools into course materials or data challenges. Data providers can add to the catalog, track the usage of the data through NDP, and then they can also support documentation, metadata standards to help with it with some educational materials. Students, learners can come in and find methods using real data. So the idea is to add more to those. So we have a repository of things for students to informally learn, but also build and share projects within data challenges or contribute to team-based work or take classroom assignments shared by their professors. And then the platform component, again, when we take it to near data services or endpoints or adding composable services on top of NDP, we also have ways to create service stacks that are standardized with NDP. So whatever is built can be a part of the platform, and then maybe even take it out of NDP to then create what we call branded hubs or custom NDPs. I'll show an example of that today. So how does NDP do this? We have, again, the main thing here is this catalog. It's a catalog of all things, and those are federatable, composable things. And one can definitely bring into the catalog services that are near data compatible at a data point of presence. We can also include storage and compute compatibility through national systems like OSDF, Pelican, so that we can create that data delivery compatibility with compute. And one can discover things in this catalog and start collecting them into their workspaces. It could be data models, services, scripts, Docker images, and their own mini catalogs even can be in a workspace or workflows. Right? That requires integration of workflow engines together with the deployment of them. And then these workspaces can be available through the Collab Studio to classrooms, projects, or data challenges with persistent volumes and storage to share between the collaborators. And NDP itself is a user interface shell. What does that mean? It's a branded shell. That's the NDP. That's the main thing. But one can also, as I mentioned before, create branded external hubs. So with facilities, I thought about we can sort of maybe think through with some of you is how can you use it, right? Facility data can be cataloged in NDP together with other things that you're using to bring some integration and interoperability with other data sets. Maybe on their own, then the discovered data from facilities can be used in AI and other complex scientific workflows. And one thing that we face a lot, and I'll give an example with EarthScope today, is facility data lives in an archive, and how do we add services to it? So we can add now near data deployment, near data services in that sense, in standardized way with NDP, So then we can interact with the data without moving it through those services. One can create custom hubs for groups of users through these endpoint services in a combination of NDP, CNDP, custom NDP capabilities, and NDP endpoints. And we would love to work with you in this lasting of materials and tutorials and in general, making classroom capabilities involving facility data. And we think we have a very standardized workflow for that. As we learn more, we can expand those. So, okay, how does discovery happen? There is a multimodal search capability, and again, being a young project, we are still continuously customizing and updating and making it better, but we can do metadata-based search, conceptual search in ways that includes network graphs and very soon, hopefully, conversational interfaces in this quarter that we're in that uses these knowledge graphs. There is a capability that gives us map-based and temporal search, basically spatio-temporal search in ways that connect with the rest of the data catalog. And what's happening right now is actually integrating the data sets, some of them as the ingestings, with something that we call democratizing data services. So this gives us more understanding of usage of data in scientific context and through AI agents that look for how data is used. And some NDP data sets, when you go, you'll see a little insights icon next to them. That's when one can explore these dashboards. And as I mentioned, conversational search is one of our plans for the end of 2025. So then the catalog can accept new items. One can come in and register data sets in the catalog. There's a metadata crosswalk from many metadata standards we are working on, for instance, Croissant. And we are expanding this and trying to understand what would be compatible ways to use existing standards and create some interoperability. And data can be added with some links. And also if there are things like links to, for instance, OSDF, one can provide that. So when that data set is used in this NDP launched workspace, on this time, this one is in the National Data Platform, then when we work with that data and add that workspace into the National Data Platform, when that data is loaded, it's already fetched by OSDF without user having to do something about that using the Pelican software interfaces. I'm going to go pretty quickly through these because there are some examples. So what are existing data sets? We are trying to expand on any data set that comes into NDP. We are trying to see if there is a use we can generate, so examples can be there for whoever wants to use the data can learn from and expand. HydroFrame and Hydrogen Digital Twin is a national scale effort for hydrologic modeling and also emulator development on top of that. The data is already listed on the HydroFrame archive, simulation data and other data sets for AI-ready data sets. But our collaboration with HydroFrame was on integrating the data with NDP catalogs. I still keep not changing the slide, but actually final data has been there for a couple of months. It says waiting for final data steward. The data has been there for a couple of months, and we are also doing AI workflow integration using the National Research Platform to show examples of the use of the data. And also being discussed is a data challenge using this data set. Another example from actually the astronomy domain is from a telescope and other instruments that provides solar simulation data stored on OSDF already via the Pelican interface. This data was cataloged by Kurt Dodds, the research software engineer who stewards the data and compute resources needed for this analysis. So, and NDP now catalogs this multimodal data, and the data comes with exploratory Jupyter notebooks, so explore the data and data to be fetched by OSDF. And one of the things that we are tinkering through is how the Education Hub can be used to then deliver interactive course content to teach with this data to students. And NDP comes in a couple different ways here, because Kurt definitely wants to create these tutorials and make it available on research infrastructure. But there's an on-prem HPC resource that has the active data in Hawaii, and then the full data set gets moved to Johns Hopkins, and an ability to use that through an NDP endpoint in the future is a possibility that we are exploring. Another example is from biologging domain. This actually Jessie Kendall-Barr cataloged her multimodal sensor data and video data and electrophysiology data along with GPS trackers on OSDF and cataloged it on NDP. So a goal here is then use these data sets for time series analysis that gives us more understanding of, in this particular example actually, is the sleep patterns of extreme divers like whales and other species. But in general, animals out in the wild, so to say, their physiology and their behavior patterns can be analyzed with similar integration. So then endpoints, right? What do the endpoints do? Endpoints actually can be deployed through the NDP Hub, and by the end of 2025, also the deployment of the endpoints will be facilitated through the Hub. That's still coming soon, kind of capability that we are working on. But the endpoints can be discovered and added to the NDP catalog so that we can actually use near data services on various data resources or compute resources or other compute capable services and federate those as services into a workflow. So they actually know how to communicate their own compute and other things as deployed by the service providers. The endpoints also is compatible with things like AWS. So configuration of an endpoint, configuring, in this case, an EC2 instance, and launching those endpoints in ways that then could be useful through either an endpoint deployment or an NDP is a part of the goal here. And this particular mode was used, for instance, for Earthscope data on AWS. So NDP stack of workspace access and data search and discovery was integrated with also the endpoint streaming services deployed. So what does the endpoint provide here? It provides a key cloak compatible authentication and authorization, a mini catalog to the facility data coming from Earthscope. And on top of that, development of the SciDX service by our Utah collaborators, but it could be anyone in that sense building a service of their own to create data delivery or streaming or other AI capabilities. So then that service can be made available through authentication authorization with as a role-based access with whoever they could be useful to. And also historical data through this can be streamed into OSDF Pelican for more analysis and modeling or retraining on, for instance, OSG in this case. So this was demonstrated as an individual capability as services sitting on the Earthscope, near Earthscope data on AWS. Of course, if that service is available, what does composability mean? When we use that service, let's say we can also combine it with things like data services developed by, or simulations developed by Crescent, so that they can be used to validate some things that are being done in like fake quakes data, for instance, in Crescent. So different endpoints can be integrated through the hub or other endpoint workflows in a way that are composable and interoperable with each other. I can talk more about these if there are questions later. Similarly, data facilities for NASA and NOAA can be integrated through services, so the egress charges can be avoided through endpoint deployment. And also we can interoperate the data, let's say satellite data from these different data, Earth observing satellite data capable facilities. So those were the endpoints. I'm going really fast through those. And how does MVP do it? We said the integration of workspaces. By the way, one can find, for instance, Hugging Face data and models with an NDP. And then they can put them in, let me move that a little bit, into a workspace. And that workspace then can be, let's say the HLS burn scars. This was actually a NAIR data set that was on the NAIR pilot website that we are now bringing that into a workspace, the Hugging Face service provided in there, and deploying that particular container on NRP on the Jupyter Hub. So what will it open is this workspace that then helps us to use the National Research Platform to learn from what was shared. So this was built, of course, as an example, but anyone publishing data and models using Croissant and other standards in Hugging Face can do a very similar thing in NDP to then bring them to either tutorial settings or research integration settings. So this gives us the rest of the AI workflow as a movie and an example. Of course, one can also deploy compute endpoints. I'll play the movies. This is a test workspace apparently, and then data in workspace are discovered through NDP and placed into that workspace. And this is the Jupyter Hub on NRP or an endpoint, a compute endpoint in on-prem on Utah can be integrated from here. And then when they open that workspace Jupyter integration, oops, what happened there? Then they can load the workspace and do the look at the data in this case and do some analysis with the data. So I mentioned Pelican before, right? When we go to the Jupyter Hub, the data is actually already OSDF compatible in this case. And the service, let's say, started up. When one adds these data sets that are OSDF capable to the workspace, you see actually this was downloaded, and then the data sets that are downloaded can be used in ways that make the data fetched automatically using OSDF and but wherever the nearest cache is. If you don't know about OSDF, I think Brian Buckman already gave a seminar a couple of weeks ago. It enables caching of data across the cyber infrastructure by integration of different storage endpoints and origins. And in NDP, we built a capability that's very compatible with OSDF to discover data that's already on OSDF and use it in scientific workflows in ways that NDP fetches the data in the workspace together with other data sets that the data needs to be used and analyzed with. So this helps us actually to use data in educational facilities, right? In a data science class, it's really hard to have the students work with research-grade data sets. As I mentioned before, this actually shows an example from a class from fall 2024, last year. 6 students group used about 40 gigabytes of graph data One of them was on the, for instance, patent data that was shared on the NAIR data set as a NAIR data set at the time. And the students accessed the data, added their own private data sets together with it when they found them, and used the national research platform to analyze these data sets that required a lot of memory actually per node to do this. And in this case, NDP administered the Neo4j graph database for the faculty member, and we are working on ways to integrate other administration of these services so that the education workflow can be integrated into the support in different universities and settings. The other example that I'd like to provide is the data hubs or data challenges. I think this would be, I'm hoping, really useful to those of you in the audience. There is a way for then integrating these workspaces in data challenge, informal data challenge settings. What we are looking at here is a data challenge actually that was called Fire Ready Forests. The students can team up and join the challenge and share the challenge experience as teams. And what NDP provided here is learning modules as workspaces in the first place that students can go and collectively access and learn from. And it builds their experience, for instance, to understand how to work with 85 gigabytes of data on large-scale computing resources. They teach them about scalable computing environments. They learned about generating machine learning-based analysis on aerial and terrestrial LiDAR data sets and forest inventory data in this case, and fast fields database. But then the last sprint, so to say, the last workspace was made for them to empty, to answer the question of how do you then predict tree species using LiDAR data. So we made this accessible to UCSD students, thinking that, that was at the time the first challenge. But then what we noticed is through the onboarding module, students from 8 different universities actually found and self-onboarded and took the challenge. So this is really, in that sense, the first time, I think, totally online this happened without help, because students were able to find the challenge, onboard themselves, learn, and submit. And the judges then was able to review those submissions through the platform in reproducible ways. So this is, I think, has a lot of potential for getting more value out of facility data sets for education or data challenge use in interoperable ways as well. And the winning solution, which we are seeing actually on the movie right now, was then made available through NDP as a learning resource. So the idea is then, as we learn, as I mentioned, through these co-design, co-development efforts, we are adding those as learning resources for capacity building of different sorts. This was also shared at PERC, winning the best paper over the summer. So the paper explains more about this. So all of our work, like Burn for 3D is, for instance, my project with my collaborators and team members. We are now sharing our data actually through OSDF and making them accessible to our collaborators or classrooms through NDP. We also do a lot of digital twin and AI integration applications in my team. So we are using NDP right now as a digital twin factory, using composable services about data sets from the physical system to link them to the digital system. This work was shared, at least the starts of this work was shared at Flex Science in 2025. But I would love to talk to you more if you're interested in these type of applications. And one of those digital twins is these immersive environments. We are using this data system to create a contextualization engine through services on NDP. And then we are using them in like some presentation environments. For instance, in this case, this is a 3D Unreal-based movie or like immersive environment that we can interact with the avatar to understand. And like, for instance, we have the shrubs tree metrics coming from LiDAR sensing and other plots that we have. We can integrate them into the scenes, this point cloud scenes, so that we can see the results of different AIs, or like the things that give us tree species or tree type or tree metrics, or their burnability. For instance, these are all different AI-based services that run on the data in NDP endpoints and gets integrated in this digital twin immersive environment. So it gives us also this type of capabilities that we can bring more data into these digital twins ourselves. Isaac is my PhD student. And then the last thing I want to talk about is how do you customize NDP? Again, we are a big needs assessment. The pilot as wildfire as an area because of, in a way, what my team does, along with earthquake and food security. We have other examples as well. But one of the major things that happened over the last year is the launch of the Wildfire Commons. It says planned to launch July 1st because I didn't update the slides, but we launched it in July. And the Wildfire Commons is an NDP, custom NDP environment, CNDP, so to say, that's completely built on the NDP's core functionality. So the catalog, dashboards, compute, compatibility, and authentication access control through Keycloak is used in the site as a branded website. And the other white things are the parts of that commons itself, but curated catalogs and Fireforge is an NDP capability. So Fireforge is what I'm going to show you right now. Then you come into actually the Wildfire Commons, you'll see very similar interfaces like NDP in a way that customizes the NDP experience to wildfire experts from different cross-sector backgrounds. And let's say in our case, we want to do some things in the Wildfire Commons that show up. This is Points to Panel, one of the apps that we built. You see in this setting a LiDAR context with some tree metrics in greens here calculated. It's basal area in this particular case. And how do we generate these scenes through LiDAR data in NDP or the Wildfire Commons in this case? So one thing that Letitia, our teammate, is doing is creating a workspace, preparing the data in it, add processing scripts by Isaac into it, and then create this with collaborators in a Collab Studio research project. They can add group members and then launch the workspace to compute. So what we'll see here is actually Letitia then entering the Fireforge, exploring the community catalog, adding those catalog items into a workspace. Actually, she didn't add the workspace yet, but she's adding a curated catalog in this case, and then it's going to add that catalog into the workspace. So then we can find data and add it to that catalog and search that catalog then in the next one after we prepare the data to create a workspace. This is a terrestrial LiDAR scan processing workspace. Getting a Git repository provided by our student Isaac, and then adding from that curated catalog into the workspace so we can go back and use that curated catalog time after time. Then she's building a project for collaborators. This is Independence Lake scans, and the collaborators working there, burn bosses and others, vegetation managers working in that area, they can be added. In this case, we are adding the tutor and NDP, so it's not real collaborators. And now that collaborative project is there, we can create a workspace and add to that collaborative project. Oh no, I'm sorry. We can open up the collaborative project and launch that workspace into the National Research Platform with the resources that they want. And what they'll end up in is this Allfire, again, branded workspace integration. So how do we use this workspace then? We can load that. I'm going to try to go to. We can load that workspace that she just created. We can clone the Git repository there, and we can fetch those data sets on OSDF into the platform. And I'm going to quickly play. This one happens in RStudio, the analysis. So they're opening the data and the RStudio component. And at the end of that analysis, that one particular image, one of the things that you will see in the points to panel app that I showed is created. So that app uses OSDF data in the backend for something else as a service. How do we then share this in OSDF? And that's the last step. One can add their Pelican credentials and upload the files to their namespace there. And then it's uploaded to the Ceph storage block and not as an origin, and then it's already in the OSDF compatible storage origin in that namespace. So I tried to quickly overview, I'm sorry for the long presentation, NDT capabilities. I also I tried to link that to some of the facility needs that we learned in our needs assessment over time through Earthscope and others that we worked with. And I hope I get to interact with some of you over the next couple of months to see how we could collaborate and create some maybe endpoints and other custom interfaces within NDP. Thank you.
All right, well, we're at the hour, so please, everyone, join me in thanking our speaker, Ilkay. Thank you very much.
Thank you so much for your time. Bye.